Okay, we go Kramer's rule. I'm going to give you the rule for a 2 by 2 matrix first, and then the rule for a 3 by 3 is the same idea. I'm just not going to write it out for you because, well, I guess I sort of can, but anyway. For a system of equations, ax plus by equals a constant s, cx plus dy equals a constant t, we can find x by taking determinant x divided by determinant d, and find the value for y by taking determinant y divided by determinant d. And that's with determinant d being the determinant for our main coefficient matrix. So you can see that that's just the one we've just been doing, where we take these numbers next to x and y, turn it into a matrix, find the determinant of that, that's d. Okay? dx, you take the x column and you replace it with the constants. X column replaced with constants, s and t, and then you find another determinant for that. Then you take this number that you get from this determinant and this number that you get from this determinant, and you divide those numbers, and that magically gives you the answer for x for this system. It's pretty cool. What do you think dy is? Yeah, you switch out the y's. So the x's stay the same as they were originally, but this time we trade the y values with the constants. So y column replaced with constants. So to solve a 2 by 2 system, find your x and y value that make that system true. You just find 3 determinants, and then you divide them and get your answers. How is it going to be a little bit different for a 3 by 3? You have 3 columns, so you'll have 4 determinants, and the 4 determinants are those big ugly problems we just did one of. So a 2 by 2 is really fast and easy. A 3 by 3 is quite a bit more time consuming. But it's still straightforward. It's still, you're not making decisions about what should I multiply and add next. It's all just formula answer, even though they're a little bit long and tedious. Okay? Let's go ahead and do a 2 by 2 problem that we saw earlier. Actually, let's do a 3 by 3 first, just for fun. The way that I'm going to shorten this, though, is I'm going to say solve for z using Kramer's rule. So I'm shortening the problem by saying just find z. Let's not worry about x and y. Okay? And the problem we are going to do is 2x plus y minus z equals 3, negative x plus 2y plus 4z equals negative 3, x minus 2y minus 3z equals 4. So to find d, we would do the determinant 2, 1, negative 1, negative 1, 2, 4, 1, negative 2, negative 3. Does that sound familiar by any chance? Does anyone recognize those numbers? It's the one we just barely did. And what was the answer? 5. We just did this one. Okay, so now to find z, what do we need next? determinant of Z. So we take our constants and we replace column Z with the constants. So we're going to have the same x's and y's, but different z's. Always double check your numbers. It's so easy to make a little mistake with a positive or negative and mess up your entire solution. Okay. So we do our diagonals. 2 times 2 times 4 is 16. 1 times negative 3 times 1 is adding a negative 3. 3 times negative 1 times negative 2 is a positive 6. 1 times 2 times 3 is a positive 6, and we will subtract that one. Negative 2 times negative 3 is a positive 6 times 2 is a positive 12, but we will subtract that one. And then 4 times negative 1 is negative 4 times 1 is negative 4, and we will end up subtracting a negative, which is adding, correct? So 16 minus 3 is 13 plus 6. If you want to use a calculator for this, that's fine. 13 plus 6 is 19 minus 6, so those cancel out. So back to 13. Minus 12 is 1, and then minus a negative 4 is 5. Well, that's interesting. I got the same result for both determinants. You're not done till you divide them. So the answer for Z is dz divided by d, so in this case 5 divided by 5, which is 1. So Z, the solution for Z on this system of equations is 1, and we could do the same thing to find x and y.
Sorry, how did you know what to do for dz? I don't get why. What's the difference between finding d and dz? Do you know what I'm saying? Like,
Yep.
how you just replace the numbers or put them on the side, copy the numbers. I wish I could show you what I'm saying.
The numbers won't always be... Notice how we got 5 both times? That's not always going to happen. It was just a coincidence. So,
Yeah.
D, the x's are exactly the same.
Oh, okay.
This
They
one,
answered my question.
the y values are exactly the same, but the last column, this one was the z's, this one is the constants.
Okay.
So if you were to do x or y, you would replace x with those numbers, or replace y with those numbers, and then you would keep the originals of the others. Okay, are we good? Okay, let's do a 2 by